Let me first briefly introduce Professor Qifeng Chen. Professor Qifeng Chen is an associate professor in computer science and engineering at Hong Kong University of Science and Technology. Professor Chen received a PhD in computer science from Stanford University in 2017 and a bachelor degree in computer science and math from Hong Kong University of Science and Technology in 2012. His research interests include computer vision, machine learning optimization, and computer graphics. And Professor Chen's work has received numerous awards. And for instance, his work has won the best AI 2021, and he also has won Google's Faculty Research Award in 2018. He was named as one of 35 innovator under 35 in China in 2018 by MIT Technology Review, and he won gold medal, second place worldwide and North American champions at ACM ICPC World Finals in 2011. So let's welcome Professor Qifeng Chen to talk about his research on generative AI and generative editing.
Thanks very much for the introduction. And let me share the slides first. Okay. So I hope you can see the slides. Let me make it full screen. Okay. Can you see the slides? Okay, I assume you can see the slides. Hi everyone, I'm Qifeng, and I'm very happy to share our research on video generation and editing, and many of work can provide users some interaction with the video generation process. And many of you would know there is some great work from different companies in terms of text to video generation. For example, Sora by OpenAI last year. And I believe one of the most popular video generation tool would be Qifeng by the Chinese company Kuaishou. And I have seen many cool videos generated by Qifeng. And other companies like Meta also has its own video generation tools. And in terms of open source text to video generation platforms, and the Chinese company Tencent has this Hunyuan Video. It's open source, and where now we can generate high quality videos with this tool. And a couple of days ago, the other startup, Stefan, has another open source tool for text to video generation called a Step Video. And the video quality is also outstanding. So we have seen many this kind of video generation tools. And we can apply this kind of tool to for some applications. Let me show one example here. We can use this kind of tool to generate extremely high resolution video. And in this example, so we HKUST recently has Shanghai Center and make the AI generated video for this sector. Part of the demo here. The task is not that easy because we need to generate an extremely high resolution video like 11 and 200, 11,200 units of the width. It is actually no existing AI tool can allow us to do this in AutoCAD. Different techniques together in such a one video.
你说配合那个动作是哪个？
We can utilize the AI tools today according to our technology. We can create very high resolution video, and we don't have to capture the video by ourselves. Just provide the script of the video. So here are some example in the end. We have the engine that looks like this. The birds and we call it the red bird.
那边不动了。
Okay, so here is one example where we can actually apply AI to generate video for the real application. And here is another example. We can make some music video. So we can also use AI to generate an animation. Actually, we can music. So we train a model that dedicated for animation, and then we usually one simple solution is we can generate the image for that frame, and then we can animate the image, make a short video, and then we can together. But one challenge is how we can maintain the character consistency and make the style of the whole video to be consistent. So you can see now with this kind of AI tools, text to videos or image to video, we can generate an animation at a very low cost. It will just take a few iteration, to select the video clip we really like, and then combine them together. So this is some potential application this kind of tools. Okay, and so many existing tools can only do one thing, is just video generation, but it doesn't contain audio. And how about we can do the both video and audio generation? And some of our recent work, like this one, you might have seen some of this generated by Sora, just like a star. So we can create as well, so that we don't have to find the audio to match the video we generate. So it will be much more convenient. Yeah, and our work was the very early work on this direction, and later I will talk about how we can achieve such a result. When we generate the video with AI, we can also create the sound that accompany, especially the audio needs to be well synchronized. Look at this video. They're likely sounds also synchronized with the video. So our video generation roadmap, on one hand, we would want to develop the video foundation model. And actually, we started building the video foundation model in 2022. That's 3 years ago. We have the earliest open source text to video tools. Unfortunately, we don't have enough GPU and resources to build a best foundation model today. And with some foundation model, we can have some user-friendly functionalities. For example, how we can control the character, how we can animate an image, and how we can add the audio to the video content, or we can edit the video to serve our purpose. So we can see some of the example. Before that, we will talk about some my journey on the video generation. Okay, so to make a outstanding video, in fact, the pre-training stage, which is building the video foundation model, is the key. And in 2022, we already have at UST, we already built the very early latent video diffusion models. And in fact, diffusion models are the primary model we use today to build the no matter image or video generation. And at that time, some other companies like Google and Meta, they also have some demos on how to generate a short video, and but they are not open source. And later we work with Tencent. We have in 2023 we have open source video crafter one that's even before the Sora, and it became a very popular tool for academic research in terms of the text to video generation. Okay, so in fact, in Video Crafter, we already have the the model that combines diffusion as well as the transformer blocks to build a powerful video generation framework. And we can see some demo we built about 2 years ago. So although it's not state of the art, but we can have a look at what we have already achieved about 2 years ago. Nice. It's not very good in today's standard. At that time, I think it was state of the art. And we can one important thing is it was open source back in 2023. So then I think that could be inspiring and inspire researchers to be, according to the scaling law, if we build more, have more data, we have a larger model, we expect to have stronger results. And with this kind of framework, and then in fact having infinitely generated infinitely long video is not that difficult. For example, combined with FIFO, and we can have a simple solution to generate infinitely long video. So actually the length for consistent video generation is no longer a limitation. So that's about the video length. And how about the video resolution? You can imagine if we want to build an extremely high resolution video, it would be expensive if we just train the model on high resolution video. And how about if we only train a model on relatively low resolution? Okay, it's not very low, like 480p or 720p videos, and but can we generate 2K videos directly? So in ICLR last year, and the work actually was completed in 2023, and we have a simple solution that we can generate 2K videos directly, without training on high resolution videos. One issue we found at that time was if we train a model on low resolution videos, but test it directly on to generate high resolution video, we will see some duplication issues of objects. And the reason we found was the object, we use convolutional neural networks in the diffusion model. So it has actually a relatively small receptive field. So we try different types of ways to increase the receptive field. One way we have tried is called this retilation. So what does it mean? It means during training, we don't use dilation. We use dilation rate 1. That means we don't use dilated convolution. But during the test time, we can try like dilation of 2 to increase the receptive field. So with such a simple approach, we can already see a significant improvement. However, if we want to have the increase of the resolution by a factor of not just 2 or 4, but by a factor of 1.5, then we need to have a more advanced way to achieve that. So we also come up with other type of dilation, including this fractional dilated convolution to do that. And we also explore other types of way to increase the receptive field, including dispersed convolution. That means we can use, maybe originally we used 3x3 convolution, but we can try another convolution like a 5x5 that match the behavior we have in 3x3 convolution. And during the test time, we would use like this 5x5 convolution to perform the inference. So with such a solution, we can generate 2K videos directly without training on very high resolution video. So here are some example we can achieve. So this is the example we try with the stable video diffusion model, but we test it at a much higher resolution. And you can see the result is also very good. And the idea can be also extended to just image generation. Okay, for stable diffusion, we can directly generate 4K, even 8K images, even though the model may never be trained on such a high resolution. Okay, so if you have a study like large language model, so one aspect is to have alignment with human preference. And we also propose a trick called a video DPO. First, we need to have a way to measure the video quality. We propose this Omni score, and we combine different aspects of the video. And then we can use this score to create some video pairs. Okay, so given the same prompt, we can generate multiple videos like M video. And some would give higher score, some would be having a lower score. And then we have some high quality videos and low quality video. And we can actually to use it and apply this so-called direct preference optimization to to optimize the model to generate a higher quality video, or a video have a stronger vision language alignment. And I just also checked the very recent step video, Stefan video, and they also apply a very similar strategy to improve the model. So these are some something we have tried to improve the video quality. And next we need to also to think about how we can increase the controllability when we generate a video. And in 2 years ago, the one was published in 2023. We already thinking about how we can make a short video. And one important thing we need to do is we need to maintain the character consistency. So we come up with a framework called Animate a Story, where we apply the textual inversion to embed the character concept into the model, so that when we generate a video, and we can use the same character. So here we saw a demo like the yellow print strip in China, so you can see the consistent character throughout the video. And this, we can customize what we want to achieve. We can choose the teddy bear or the bee duck as the main character for the video. So we didn't have the best video foundation model at that time, but we can demonstrate that this will be quite promising. Okay, create a short fun video with AI text-to-video framework. Okay, and we also have some technical contribution, including when we create a video, we can retrieve some relevant video like from the database, and then we can mimic the character in the existing video. Okay, for example, here are some retreated video, and we can follow the same style to create the video. So that also gives us more control what the video would be like when we generate the AI videos. Another way to control the video generation is we can control the the region where we want to do the animation. So we propose a simple framework called a follow your click. What we can do is the input would be just a input image, and we can click on the object we want to animate, and we also provide a short prompt made to say how this character will move, and we can animate the video in the way we want. For example, we click on these two vehicles, and this car should be moving backward, and this one should be moving forward, so that we can generate the video that fits our purpose. So you can see that our framework can be used to animate the background or to animate the the foreground object. Including the the cartoon style image or the natural. Actually, some are more like AI generated images. We can also animate them. And another way to another aspect for the animation would be the the portrait animation. So if we want to create a digital human, and how we can animate the motion with usually the emoji, the emotion, that's the face expression will be provided, but we want to translate this facial expression to any character, and this with our framework follow your emoji, we can generate a lot of fun videos. So we can see some demo here. So the input will include this reference image, and then the landmark for the facial expression. So our model, we can generate, a lot of these are somehow exaggerated the facial expression.
She got that booty, that type of boom boom, that bass that I like. I said,
Yeah, and our tool is already open source. So if you want to try our tool, I think you can just search for our GitHub, and you will be able to find the the GitHub to do that. Yeah. So we have talked about the character animation, the facial expression control. Then we can have a look at another aspect, like how we can control the motion. We also have another framework called a follow your pose, where in fact the input includes the human pose we want to animate, and then we can translate this. We can use this pose as the input to generate a video we want. So here we demonstrate some of the result here. Okay, and another aspect for video generation would be to do the video outpainting. So in some case, we may encounter the challenge is some video may have specific aspect ratio. Okay, it may be like a horizontal video. Okay, or it's like a vertical video. It may not fit your screen very well, and we hope to generate the content out of the existing video. So this would be the video outpainting task. Here we can just show some results. The middle part would be the input video, and we can generate the other parts. Yeah, so the region out of the center box would be generated by our method. So you can see the generated region would be also quite natural. Okay, and we can make some comparison with existing methods. This is other baselines. You can see the painted result is not very good in the clear boundary, and our result is much better. And we can also use the text to control what kind of content we want to add to the outer region of the video. So this shows different applications and how we can control the video generation or editing we want. Okay, so next we can further look at the joint video and audio generation, which we have seen some demo at the beginning. So the idea we want to achieve here is we want to have a unified framework where we can do multiple tasks together. So not just generating the video, but we want to also do joint video and audio generation. Or this is already a very good application, video to audio generation. Other related tasks including audio to video generation or image to audio generation. So what we found at that time is, there are already some very good pre-trained foundation models. And if we are able to align the audio signal and the video signal in the same latent space, they can match each other, maybe the result would be good enough. So our key idea is in the with this kind of pre-trained diffusion model, and we can apply this image buying model. Image buying is a multimodality alignment model proposed by Meta. And if the generated video and the generated audio can be matched in the image bind space, maybe the result could be would already be what we really want. Yeah, so with such a mindset, we have created a framework to do this kind of task. So I'm not going to go to the detail, but we can have a look at more examples. Wait a second. This is some baseline. Audio result is not correct. The teacher giving a lecture. So this is our result. Here we can see some examples. We can even do. We didn't use a very powerful foundation model, but we can see some, some result that matches the audio signal. So this is some baseline, and this is the result we create. Okay, so we have talked about the video generation with some kind of user control and joint video audio generation. And how about editing a video? Yeah, so that would be useful. When you generate a video, it may not serve your purpose. You want to improve it. And one way we can edit a video is through some consistent translation of the video. Let me show some of the result first. So the first video you see is the original video, maybe from some movie clip, and then we can use the text to control what kind of content we create. And so the original video gives us the motion, and then we can use the text to describe what kind of video we want to achieve. Here is another example. We can turn a video to the Chinese ink style. Technically, we propose a very general framework. We can adopt any image processing algorithm to videos. So the result we saw just now is we adopt a famous image editing method called the control net, but we can apply it to videos. The way we did it is we adopt the idea from Nerve. The idea where in Nerve we would build a neural field for XYZ, the 3D space. But for video, we focus on XYT. We want to learn a deformation field, then map each pixel. Each pixel in a video can be represented by XYT. XY is the spatial location, and the T is the index for the frame. And then we map it to learn a displacement, to map it to the canonical image so that we can generate consistent result. So here are some more demo videos you can see where we can adopt various image processing algorithm to videos so that the generated video can be still temporally coherent. And this is SAM, which is a segmentation method where we can also make it work for video. And here we saw different video translation result given the same input video. And we can also adopt it to digital to human face. And another cool application would be the video editing. That would be where we can easily change the video content just by a few texts. Here we saw a demo. Given an input video, we can select, okay, that the input the user needs to provide would be a silver Jeep, and we want to change it to a Porsche car, okay? And you can see now, when we make a video, we don't, we can just capture video first and then change it the car we really want. And notice the work we did, was done in 2023. We don't even have the video foundation model at that time. We only apply the stable diffusion, and we can already achieve such a result. Okay. The general idea is we would apply the so-called DDIM inversion, where we can translate each frame into the latent space. So we have the inverted the latent space, and then when we want to reconstruct the edited video, we will remove the latent for the object of interest and add the latent code we are interested in, so that we can regenerate a video we really want. Okay, so this is we call it the Fate Zero. It was also quite a popular video editing tool. And lastly, I would introduce our recent open source framework called a video tuner. It's a general toolkit if you want to do some video generation or editing research. I would recommend you to try the video tuner. So in this platform, we already include a lot of existing open source video generation tools, and you can easily to do the post training, and you can adopt the model to your own data. This includes some existing tools like 混元 video, OpenSora Video Crafter, Flux, Dynamic Crafter for image to video generation, Code Video X. Okay, these are some open source video generation tools, and you can easily deploy these tools with our video tuner toolkit. Yeah, so here are some examples. We can use a video tuner to generate some video. So actually, we demonstrate this example to Jensen Huang when he visited the HKUST last year, and he was amazed by this kind of video generation result. And we built a different kind of user-friendly platform for different applications. Including facial video generation. We can fine-tune the model for some specific character. And we also have a video compression framework called a 3D video VAE that has stronger compression rate, but at the same time has strong reconstruction ability.
Un poco a Terminator 2, ¿no? A ese momento.
yeah, some examples. So if you are interested, you can go to the video container GitHub, and you want to talk with the primary author, you can chat with my PhD student on WeChat about this tool. With this tool, you can also fine-tune the model with LoRa or DPO, various applications. Okay, so today have shared a lot of different applications with the AI generated videos, and I hope this kind of result could be interesting, and you can learn something and use these tools in case you want to do some related research. Thank you very much. Yeah, if you have any question, I would be happy to answer them.
Yes, thank you for Professor Chen's great seminar. And from the audience.
Really? Yeah, but I have a question. And firstly, thank you, Professor Chen, for the nice presentation and for all of the video generation and editing. And yeah, and I have a very it's an open question about the united model. As we know, recently we had some united model from the understanding and generative models. So, for example, Janus Pro or Vila U. And because I know in your lab, in all the multi-module large language models, for example, about the multiple modality and sounds, language, and image and video. And so my question is about the what's the main challenges about the united models? As your perspective.
So I think it's quite possible to unite different modality in the same framework. So one approach is we can tokenize all the different types of modality data as a token. Okay, we can have an image token, video token, audio token, and then we can process certainly text token. We can process them in the same way using this large language model to do that, including even action. There are action tokens today. However, there are also challenges because in video generation models or image generation models, diffusion models are still the very popular framework we use, and it's not very consistent with other language models. So there are some effort that try to combine them together, but the result is in terms of the visual content generation, diffusion model is still the state of the art. Yeah. So the autoregressive method for video generation is a promising direction. But maybe in the future we can unite them together in the same framework. Yeah. But currently it's still a challenge. Yeah.
Yeah, and I think another challenge is about the data, because we do not have the enough data combine all modalities like language, sounds, and the images. If we do not have the enough data, how to train a model in a united model. It's about the training strategy. I'm not sure but it's the next. Yeah.
Yeah, this is a very good question. In fact, we can show that it's not necessary to train the model with all the modalities together. So what we found is okay, we have some pre-trained the model to do the text to audio. Some would do the text to video, some would be text to image. And as long as the content we generate can be aligned in the latent space with some pre-trained model, then we already have strong regularization when we want to build, when we want to generate the content we want. This is just a solution, but I think it may not be good enough.
Yeah.
But I believe this could be a starting point. Ideally, I believe we may want to collect a really large data set that combines different modality and do the joint training together.
Yeah. Thank you so much.
Thank you very much, Ming Han.
Yeah.
I see a question from the chat room. What is your envision that video generation and editing can be applied in some healthcare application, such as surgical videos? Okay, that would be a very good question. I think that potentially many applications. One is we can do the you know, the data augmentation. So now if I believe in medical applications, we may encounter some cases we don't have a lot of relevant data for training a model. So one way is we can use this kind of a generative model to generate more medical data, so that and after that, certainly the generated video may not be perfect, but we can have some expert to do the filtering, and after that maybe we can do some labeling for the generated video. Another application would be we can do the video prediction. So if we have the observation of the same patient over time, so we can predict how the the medical images or symptoms would evolve over time. So this is what the the model would be also good at. Because if we have trained a model on a lot of video data, I believe it has this kind of ability. Yeah. So I think that I'm not expert in this healthcare application, but that's something I can imagine. Yeah.
I have a question.
Mhm.
Yeah, I think for tech,
Sorry, I think
definitely
your
see.
connection.
Hello, can you hear me?
It's fine now.
Yeah. Yeah, we have definitely see text generation or image generation. They have seen great utility in practical business. Yeah, you can use it to generate posters. People are already using them. But how far you think the video generation could be really used by the artists to or directors to generate real movie, that would be that would be commercially valuable, or still there's quite far distance, because I think the temporal consistency is a big concern for any movie generation, right? Because you don't want your character change its appearance over time.
Yes. So currently, it's still hard to generate video directly matches the movie quality. But I have seen a lot of AI generated video on Douyin, on TikTok. Okay, that's already very exciting and somehow realistic. Like this week I saw a video about哪吒versus Captain America. So I could share that with you later. And we see I saw a video where哪吒is fighting against Captain America, and it's quite realistic. And so I think the video is generated by AI is already quite good. And in the future, I think we can soon, maybe next year, we start to see even in cinema, we see AI generated videos. The progress of AI video generation is significant. Within the past year, I think the quality of AI videos is from videos with a lot of artifacts. Now it's hard to see whether sometimes it's hard to tell whether it's generated or not. So I think very soon we will see some AI movies.
Yeah. I have a new question. It's a specific question about the series of papers about the follow your post or follow your emojis. I know each paper is good, but I just think is it possible we combine them together? For example, in a video, if there has a person, and then we can control his or her pose and then emoji. If we can combine them together, that means we can push them to the real world applications. So
yeah, I think so. It's more or less like you have a Photoshop. There are many tools, and each function corresponds to one of the tool. And we don't have a good interface to combine them together, but we can apply these techniques in a sequential order, to edit the video we want.
yeah, in sequential order is a way, but if we can, for example, automatically combine them, it's better.
Yeah, that's a very good suggestion. Yeah, we can look into that to have a more unified framework.
Thank you.
Yeah, thank you for the suggestion.
Any more questions? It's a great opportunity to interact with Professor Chen. And feel free to ask questions. Okay, if no more questions, we will thank Professor Chen's great presentation, and and we end the seminar.
Yeah, thank you very much.
Thank you so much. Nice presentation.
Thank you.
Thank you.
Have a good day.
Yeah, you too.
Thank you. Bye-bye.
Bye-bye.